Hello, everyone. Thank you for having me. It's a pleasure to speak today about the sanctuary of the Hathor Shrine in the Hatshepsut Temple at Deir el-Bahari, about the preliminary research of the polychrome relief decoration. Studies on technology and conservation are two main objectives of the grant project that I conduct within the Polish-Egyptian Archaeological and Conservation Expedition, a joint project of Polish Center of Mediterranean Archaeology and Ministry of Tourism and Antiquities. Project itself is funded by the Polish Ministry of Science and Higher Education under Perły Nauki grant competition, and it is carried out as a part of a broader umbrella initiative focused on the reconstruction and conservation of the Hathor cult complex, led by main conservator Monika Czerniec and Professor Krzysztof Chmielewski from the Faculty of Conservation and Restoration of Works of Art at the Academy of Fine Arts in Warsaw. Temple of Hatshepsut is located in the heart of the Theban necropolis. Serving as the temple of million years, it's a unique architectural complex built in the 15th century BC. The Hathor Shrine, marked here in red, is situated in the southwestern part of the middle courtyard of the temple. It was one of the earliest complexes built in the temple, with its western part embedded in the Esna shale rock formation. The shrine stands out as one of the largest and most prominent structures within the temple. It comprises of two Hypostyle Halls, a vestibule, and a bark hall, all leading to the main sanctuary, which is the topic of today's talk. The sanctuary is a rectangular room with a vaulted ceiling and two niches symmetrically placed in the northern and southern walls. And sorry, it appears that again, this should be visible. Okay. It is one of the few parts of the temple where depictions of Hatshepsut have survived. The entrance to the sanctuary is located on the eastern wall, above which you can see a motif originating from the 12th dynasty, a combination of a winged solar disk with a cartouche element. The western wall portrays Hatshepsut as a male king, wearing a false beard and a double crown, protected by Hathor and Amun. The vaulted ceiling is adorned with stars. On the northern and southern walls, there are scenes approximately 3.6 meters wide and 2.2 meters high, depicting what was originally in the sanctuary, a statue of Hathor in the form of a cow. What's more, other scenes show Hatshepsut drinking Hathor's milk, as well as making offerings together with Thutmose III, while being under the goddess's protection. In contrast to other areas of the temple, the niches have preserved intact representations of the architect Senenmut, executed in relief and bearing remains of paint layer. And please look closely to the photograph of Senenmut, because this is the most amount of the yellow pigment you can actually find in the sanctuary, which I will talk about later in the presentation. The Hathor Shrine has been subject to several conservation, restoration, and reconstruction efforts in the past. In the 1920s and 30s, Emil Varese reconstructed the walls of the outer hypostyle of the shrine, restoring them to their full height. However, later the research of Polish-French epigraphic mission has found numerous inaccuracies in the resulting restoration. Conservation work undertaken prior to the 2000s was scarcely documented, with no available records of these activities. I've searched through the archives and was able to find some short reports from the 2000s mentioning treatments such as mechanical or chemical cleaning, consolidation of the pulverized painting layer, grout injections filling the lacuna. I've mapped this on the plan. As you can see, the colored lines and patterns mark which walls and which ceilings of the decorations were subject to conservation treatment based on reports. And as you can see, there are no marks on the sanctuary. However, it only means that these works have not been documented, as in situ observations conducted in the sanctuary recognized evidence of previous treatments, including filling of the lacuna, grout injections, and consolidation of paint layer. In addition, a comparison with photographic records revealed partial clearance of wasp nests, bird and bat excrements, and the progress of deterioration in some areas of the decoration. The project launched in 2023 seeks to identify the technique and technology of the polychrome relief decoration executed during the 18th dynasty in the sanctuary of the Hathor Shrine. It aims to document and assess the current condition of the polychrome decoration in order to establish an appropriate conservation approach. These measures are essential for carrying out the necessary conservation treatments and preparing detailed documentation. The scope of work includes in situ examination, observation, and preliminary photographic documentation in visible and ultraviolet light, as well as observation with portable digital microscope and collecting samples for scientific analysis. Let's talk about the results so far. Embedded in the rock formation, the sanctuary survived the earthquake that struck Deir el-Bahari between 12 and 900 BC. Nonetheless, the decoration of the sanctuary still suffered damage as a result of fire, human activity, and natural processes. Particularly remarkable in this context are the color changes that affected both the polychrome decoration and the substrate. Areas originally painted yellow have turned red. This phenomena is the result of transition of a yellow ochre pigment. Initially composed of hydrated iron oxides, such as goethite and limonite, the yellow pigment turns red as these minerals transition to dehydrated red iron oxide, known as red ochre, when exposed to high temperatures. Transitions of this type usually take place at temperatures above 250–300 degrees Celsius when goethite dehydrates, forming a disordered hematite. A complete crystallization of hematite occurs at temperatures exceeding 850 Celsius degrees, resulting in a red color. And here you can see both changed and unchanged stars from the Hathor Shrine, and on the right, the cross-section of the samples that we took. These were also analyzed in laboratory of Center of Research and Conservation of Antiquities in Cairo using Raman spectroscopy, and this confirmed respectively presence of hematite and goethite. These were not the only samples that we analyzed. However, we are still awaiting some of the results, and I hope to publish them once they are interpreted and compared with current state-of-art research. For now, I will be sharing only some of the preliminary insights. In many cases, for instance, in the vestibule, the original yellow color is sometimes still found in the lower parts of the walls, as you can see here on the photo, where paintings were protected from the heat by layers of rubble. This phenomena was also observed in a few Theban tombs, for example, TT 104 and 112. The transformations observed in pigments were not the only changes observed in the sanctuary. The building materials themselves exhibited a substantial loss of integrity due to exposure to environmental agents. The limestone blocks from which the sanctuary had been built significantly differed in color from the usual pale beige and were darkened to a blue-gray of varying intensity. Here on the photo on the left, you can see that blocks in the middle are significantly darker than other grayish ones, which also change their color. And here you can see these blocks mapped. Such color change is attributed to chemical reactions at high temperatures brought about by fire. The gray color is said to appear after heating the limestone to 350, 400 degrees for 10 minutes. And color changes of these types were also observed in the Sovereign Chapel of Amun in the Temple of Hatshepsut. The limestone blocks used to build the shrine are of fairly regular dimensions, but the defects of the limestone material required insertion of smaller fragments of irregular dimensions, of irregular shapes, already in the phase of initial building processing of the wall, which can be observed especially on the northern wall of the sanctuary. What's interesting, sometimes during the execution of the relief decoration, there were some changes made in the composition. For example, here you can see that one of the fragments of composition was enlarged. While examining the walls close up, I came across several places with black dripping substance. It was shiny and quite brittle. So we analyzed the sample, and FTIR analysis suggests that it is mastic resin. This is material used by ancient Egyptians for mummification. In fact, Hathor Shrine was reused for late Roman burial place. So it could mean that when the fire started, the shrine was being used for that reason. To analyze the decoration, I used more than just my eyes. I examined it also with a portable digital microscope to learn more about how the paint layers were applied, and used UV light to observe the decoration and its different luminescence in the search. Combining these two techniques allowed me to find a part of decoration with bright luminescence. This could suggest potential presence of varnish. The photo shows a narrow strip with different luminescence, the one on the left in the upper corner. And microscopic photos also show a transparent layer covering the paint layers. Samples were taken for analysis, and we are currently awaiting the results. In some rooms of Hatshepsut Temple, for example, in the upper shrine of Anubis, varnishes have been preserved on the surface of paint layer. My colleague, Monika Czerniec, who is the main conservator at the temple, discussed this in more detail during her presentation at the PCMA seminar titled Preliminary Conservation Research in the Lower Anubis Shrine. So if you're interested, you can hear more about it there. My work also consisted in a preliminary assessment of the state of preservation and identification of deterioration factors, types of damage to the limestone, plaster, painting layers. While most limestone blocks with relief decorations in the sanctuary seem to be in a quite good condition, some, particularly those located centrally in the northern and southern walls and in the ceiling, had irregular, rough surfaces that contrasted with usually smooth faces of other blocks. The inferior state of preservation of these surfaces could be linked to the poor quality of the material and exposure to damaging factors, fire, and also likely including salt decay. Many blocks, especially in the vaulted ceiling, bore remains of wasp nests as well as bird and bat excrements. The presence of such accretions on the surface of the painting reliefs is detrimental to their state of preservation, as it increases the moisture absorption and degrades the binder due to acidic content. Therefore, the state of the polychrome decoration on the stone blocks forming the vaulted ceiling varies depending on their exposure to these detrimental factors. Some blocks barely retained any paint, while others featured only a thin layer of paint that appeared washed out. The original mortar filling, the joints and irregularities in the stone blocks, is delaminating and in need of stabilization. The overlying paint flaked off, exposing spots of white mortar that draws the viewer's attention away from the polychrome decoration. Frankly, it's difficult to tell. You cannot really tell what you're looking at this moment. Also, what's characteristic for the Hatshepsut Temple and found in the sanctuary as well are the intentional traces of destruction. Reliefs bear mute testimony to the temple's historical damage, dating back to Thutmose III and the Amarna period, with indications of later Ramesside restorations. Hatshepsut images, titles were erased under Thutmose III, while damage inflicted by later Amarna iconoclasts focused on divine figures. Some of the destroyed names of Hatshepsut feature traces of guidelines in a red paint, indicative of attempts to replace them with new names. These erasures were followed by Ramesside restorations made in plaster. In the sanctuary, all four walls feature deliberate damage to Hatshepsut's relief, primarily of Amun's figure and title, which you can see here on the photo, with Ramesside restorations. However, these repairs in plaster are in much poorer condition than the original decoration from Hatshepsut's reign due to the technology and technique used. Here you can compare the original relief cut in stone from Hatshepsut time on the right, its elegance and how well preserved it is. And on the left, there is a Ramesside restoration and its quite poor state of preservation. Such differences of state of preservation between areas of decoration are ubiquitous. There are notable differences between the paint layer lying directly on the stone, on the mortar-filled imperfections, and on the joints between the blocks. When it comes to state of preservation of paint layer, even within the same substrate, the condition of the polychrome decoration varied, depending on the original technique and technology, material quality, causes of damage, location, and past renovations. There are many soot and burn marks on the surface of polychrome. And here you can see a small area where I removed the layer of soot during the first season of work to test cleaning possibilities. However, it is not only soot marks that cover the paint layer, because at present, polychrome decoration is obscured by a layer of yellowed accumulations, dirt, and likely an aged consolidant. In many places, the paint layer is darkened by old consolidant injections, such as PVA or Primo. And despite past conservation efforts, the lack of documentation complicates the interpretation of yellowish layer, which poses a challenge for its removal. I have recently completed the second season of my work in the sanctuary with aim to conserve the northern wall of it. And I must say that the cleaning of surface of polychrome was the most challenging task. The soot marks, darkening of paint layer caused by consolidant, was really the most challenging to remove. Although I've worked before on removing soot layer in the Middle Kingdom tomb, here it seemed to be combined with consolidant. So the cleaning of the polychrome began with mechanical methods. Loose deposits, dust were removed from the surface of the decoration using Wishap sponges. During the cleaning process, the cohesion of paint layers was checked and, if necessary, consolidated with low percentage solution of Clusel G. The red and black parts proved to have the lowest cohesion. Then the chemical cleaning was started, and tests in previous seasons gave us already some indicative on the best solvent mixture to use. Due to the sensitivity of paint layers, compresses were used. The varied state of preservation of decoration and irregular saturation of the surface with consolidating agents from previous conservation works required an individual approach. So the composition of mixtures used for cleaning was adapted locally to each fragment. For example, acetone and alcohol was added for areas with more stubborn dirt. After removing the compresses, their effect was neutralized with water compresses. Cepiolite was also added to mixture and applied over Japanese tissue in upper register. In the upper register, there were also a lot of insects' nests, which remains were carefully erased under magnification. They were removed mechanically after first softening them with compresses. The especially thick layer of yellowish consolidant was found on the lower parts of the wall. In places like this, or with dark stains and soot, it was necessary to apply the compresses multiple times. For further cleaning, compresses with ethanol acetone in various proportions, sometimes with the addition of methyl cellulose, were also used. And here you can see the comparison of on the left, the thick yellow layer on the painting, and on the right, the layer removed. The difference is striking. Unfortunately, some fragments of the decoration were so heavily saturated with old consolidants that their safe removal proved impossible. And I mean here especially the red parts of decoration, which were particularly sensitive. So after repeated trials and tests, a decision was made to only mechanically clean these areas, following the rule primum non nocere. First, do no harm, with hope of more effective methods being found in the future to remove it. Initially, it seemed that the existing putties were in relatively good condition, but work on the upper registers of the decoration revealed a number of problems. In many cases, they had been applied without prior consolidation of the substrate, and their application had been careless. They did not reach the depths of the gaps, often covering the surface of original mortar, stone, and even polychrome. The color of putties was too yellow, which distracted from the surface of original decoration. Most importantly, due to their poor cohesion, the putties did not fulfill their basic function. And as you can see, I could just put the scalpel in the fill without using much strength. The putties located in the lower parts of the decoration were characterized by better mechanical properties and were installed more aesthetically. Also, they covered large areas of substrate defects. So due to the fact that the lower parts are particularly vulnerable to mechanical damage, a decision was made to retain the existing ones. It was necessary to consolidate the unstable parts of decoration. Detached fragments were readhered with solution of conservation-grade acrylic emulsion and used after first surface reducing tension with 50% ethanol. Synthetic hydraulic lime was additionally introduced in the most detached places, and the fragments were reinforced by applying bands of putty. Material and color tests were carried out to develop the optimal composition of new fill. The best effects were achieved using a putty with a cooler shade, consisting of 1 part slaked lime, 3 parts filler with the addition of black pigment. The filler itself was a mixture of sand, limestone flour, and heap. And here you can see the transformation. First, in the upper right corner, you see state before cleaning. Then, after this was performed, the old fills, which were yellowish, were removed. The unstable fragments were readhered, and I introduced new fills in much cooler tones. And now I feel like the wall can finally breathe. The eye is no longer drawn to these yellow areas, but to the decoration itself. However, the work is far from complete because the several walls still await conservation in future seasons. Here are some of the references I've used, and if you would like to read more about this topic, I invite you to read my recently published article available in open access in Polish archaeology in Mediterranean, volume 33. I would like to thank the director of PCMA, Professor Artur Obłuski, and the director of the expedition, Dr. Patryk Chudzik, for the opportunity to conduct research, the main conservator, Monika Czerniec, for her support in the work carried out, and Professor Krzysztof Chmielewski for his scientific supervision of the project. Many thanks to those supporting the expedition work. Thank you for listening. Take care and have a good rest of the day.